Hey everybody, I'm Sean Powers, and today we are going to cover the next section in the Linux Plus certification series that we're doing. Specifically, we're going to cover archiving and compression. And if that sounds a little bit familiar, it's because we covered this topic when we did the Linux Essentials course. And a lot of what we're going to cover today was in the video that we did for that, so I'm going to go kind of quickly. Now, if I'm going too quickly and it just goes too fast, you can always go back to the video in the Linux Essentials course. I'll link to it up there, and that will give you like a slower, more in-depth look at the individual commands. But I'm gonna go quickly. We're still covering it because there are more things in the Linux Plus objectives than were specifically in the Linux Essentials. Now, in this video, we're going to go over this section, which I'm calling 1.2.4. It's actually part of the 1.2 objective for Linux Plus. A lot of this, like I said, was in Linux Essentials, but specifically, there's a couple commands that weren't even mentioned before, so I'm going to explain those. However, before I do, I want to take a minute just to thank all of the people who support me on Patreon. You'll see it's getting pretty crowded over there. I'm going to actually have to start scrolling the names, which is just so humbling on so many levels. So whether you're a Patreon supporter or you share my videos when I post them, it's because of you that I can continue doing this. So thank you so very much. Now, let's talk about the difference between archiving and compression, because there was some confusion during Linux Essentials. I want to make sure that I cover it here and make it really clear. So let's say we have a bunch of files and they are, possibly in different directories and they're in different sizes and they're just kind of scattered around our file system. When we create an archive, all we're doing is lining them up end to end. So where one file ends, the next file begins, and we just lay them all out, end to end to end, and make a single file that contains all of those other files in one file just put together. Now, the thing it does not do, though, is it doesn't squeeze the files together. They're the same exact size. They're just all put together one after another and created into a single file. And that's what archiving is talking about. Now, when we add compression, what that does is it squeezes all that single file that we've created, that archive file, it squeezes it into a smaller version of itself using compression tools. And this is a little bit confusing because if you come from a Windows background, you're probably used to zip. And zip both archives and compresses when it creates zip files. But in Linux, we do them separately. Now, we can do them at the same time, but it's two separate processes. Archiving and compressing are two separate steps. And the two tools that were not in Linux Essentials are cpio and dd. So first off, we're going to talk about cpio, which stands for copy in, copy out. And basically, this just takes a list of files on standard input. So you have to feed it a list of files, and then it dumps them as a single archive. Again, it just puts all those files together into a single uncompressed, they're the same size, bunch of data, and it actually dumps it to standard output. So you have to redirect the standard output into a file if that's what you want to do. If you want to have that archive in a file, you have to use standard input and standard output with cpio. And that's actually why it's not used terribly widely anymore. It's not really commonly used because it doesn't do a really great job of like doing any recursion. In fact, it doesn't do any looking at the file system at all. You have to completely feed it a list of every file you want it to include in the archive. All right, and you use it like this. You would say like ls to get a list of files, and then you would pipe that those results into cpio-o for I want you to output. So when you say cpio-o means I want you to output, and then you have to redirect standard output into the name of a file, and then you have your archive. And then in order to extract that out, you say something like, we'll do it on the command line, but really quickly you say cpio-i for input, and then you would use a less than arrow to redirect standard input, and you would tell it the archive file is what you want to input into cpio, and then it would dump out the file system basically that you fed it. Hopefully that makes sense. Again, it's not terribly commonly used, but we're going to go over doing it. And then the other one is DD. Now, DD, it's not really clear what it stands for, disk dump or possibly data duplicator. This is usually used for devices, like for imaging like a USB drive or for imaging a hard drive. You use it because remember, in Linux, everything is a file. So you inputted the file of like dev SDA1, and that's like the first partition on the SATA drive 1. And that you feed that as an input and it will output that to a file. So if you ever download like a .img file to write to a USB disk, you can use DD to write that image file back to a device, because again, on Linux, every device is a file, okay? So this is usually used for imaging a hard drive, and the format is you say DD and then IF equals, and then the input file. In our case, it's going to be like a hard drive device, right? Because again, every device is a file. And then OF means output file. And then you write it to like an image file. And then when you want to write that image file to a device, you just do it backwards. You say DD IF for input file equals file.img, and then OF for output file equals, and you give it the name of a device that you want to read it to. So let's do these really quickly because these are the new ones that we haven't seen before. Okay, on my hard drive here, I just have one folder full of stuff. It's actually called stuff. So if we look in the stuff folder, we'll see there's a couple files, and then there's a folder. If we look inside that folder, that directory, it's icons, and inside there's some more directories, and then inside there's some icons. So it's basically just a folder called stuff that is full of stuff, all right? If we do du-h summarize stuff, this is just going to show us it's about 97 megabytes in size. Okay, so that's how big the stuff folder is. Now let's clear the screen. All right, so now if we were to use cpio to make a copy of that, I'm going to do it wrong first, because first, if we use the example and I say ls is going to give us that one directory called stuff. So if we do ls and then we pipe that into cpio dash output, so I want it to output, and then I redirect what that output is into archive.cpio, it's going to say it only took one block. And if we look at ls minus l, it's pretty small. It's 512 bytes instead of like almost 100 megabytes, right? So something's going on. I don't know what's going on there. Well, we have to feed it a list of every single file we want it to add. And in this case, all we fed it was a folder. So it just archived an empty folder. So let's get rid of that because that is not what we want. I'm going to clear the screen. What we would actually do is something like the find command, because if you say find stuff, the find command will go through there and recursively look for every single file and directory in the stuff directory itself. So if we do that and press enter, we're going to see it lists out every single file that is in there with its full path. That's what we actually want. Okay, so let's clear the screen. We're going to say find stuff, and then that whole long list we're going to pipe into cpio dash output, and then we have to redirect standard output into a file, and that file is archive.cpio. This should take a little bit longer, a lot more blocks, right? And now if we do ls minus l, look at that archive, and it's like, yeah, it's 80 or 90, however many megabytes. It's large, right? That's the entire directory structure saved, not compressed, but saved as an archive as a cpio directory or as a cpio file. All right, so if we're brave, we could say rm minus rf stuff. So all of our stuff is gone now. All we have is that cpio file, and then to get the folders back and the directories and files back, we would say cpio dash input. Again, now we're telling cpio we want to input a file, and we use less than so that we can redirect standard input from a file, and that file is archive.cpio. Press enter, and now we have our stuff folder back. And if we look in the stuff folder, it's been recreated entirely. So that's how cpio works. I'm going to get rid of the archive thing. We don't need that anymore. But we don't use it often because standard input, standard output, and using the find command, it's kind of a pain in the butt when there are easier ways to get a recursive backup archive of a folder like that. All right, so I'm going to clear the screen. We're going to look at DD. Again, a DD can be used on files, but it isn't ever. It's only ever used for devices, usually. I guess you can make like, you can do some crazy things with it, but generally it's used on files. And so to do that, now we're going to do it on a hard drive, specifically SDA2, the second partition of our main hard drive. And normally it's a really bad idea to use DD on an active hard drive. But that's the only hard drive in our system, so I'm going to do it anyway. And the second partition is like the UEFI partition, so it's about 512 megabytes. Anyway, we're going to say sudo DD, because in order to access an actual hard drive partition, we have to have root access. So sudo DD if it's actually input file equals dev SDA2 and output file equals, I'm just going to call it SDA2.img. All right, so press enter, ask me for my password, And now it's creating an image file from that partition. Okay, it told us it completed it, and sure enough, like 513 megabytes copied, ls-l, there it is, sda2.img. Now, I could use dd and swap it around and say that the input file is that image and the output file is sda2, but since this is a currently active hard drive, that'd be a really bad idea. I could crash the system. So that's what we would do. Normally you would do it like if you're booted from a USB drive, you could do it to an internal hard drive that wasn't currently in use. All right, but that's how you go about doing it. So let's get rid of that file. Oh, I have to be root. Oh, it was already gone. Okay, apparently it wasn't write protected. Anyway, so yeah, let's talk now about tar, because tar is another way to archive files, but this is kind of the way we always do it now. So tar actually stands for tape archive, and it's because tar used to be how we would dump a file system onto a tape backup, and it's just the same tool that we use now. And by itself, it will archive files and folders recursively. But since we don't use tape drives all that much, or if we do, we want it to be compressed. And remember, by default, tar doesn't compress. We usually now use tar with the -f and a file name, because it will also create archives in a file instead of writing it directly to a tape drive. So usually we do -f and a file name, and the format is something like this. We say tar, and we're gonna do this on the command line. I just wanna show you quickly. -c for create, and then -f and the name of the file that we want it to create as an archive, as a tar archive, and then what it is we want it to add to that thing. And it will do it recursively if we give it a folder. Okay, so that's good to know. And then if we want to extract it, we have like file.tar. We would say tar-x for extract, -f and the name of the file, and then it will extract it and bring us back our archive back to our file system. So let's look at that really quickly, and then we'll move on to compression. All right, let's clear the screen, and we just have our folder full of stuff. So in order to make an archive of it, we would say tar-c for create, and then -f, the name of the thing that we want. So I'm going to say archive.tar, and then we tell it what we want it to add, and I want it to add the stuff. So we do that. And if we look, we should have archive.tar. And if we do ls-l, we're going to see, look, it's like the full size, right? It didn't compress anything. We just have a tar archive of that entire stuff folder. And we could say rm-rf stuff, so it's gone. And now if we want it back, we could say tar-x for extract, and we could do -f and the name of the file, but we could also put it right together. So we could say -xf, as long as f is the last one, because immediately after the f flag, we have to tell it the name of the file. And in this case, it's archive.tar, and now it should extract it. And if we look, sure enough, we have our stuff folder back, and everything is in our stuff folder. So we have it. Now we still have this archive.tar file. And remember, it is just about full size of that whole, all the stuff inside the stuff folder. So let's talk about compression, because tarring it is usually only the first step. We also want to compress it so we can get it in our carry-on luggage, right? We want to sit on it and get it to close. So we want to compress it, but with Linux, there's a bunch of ways to compress, and we have to look at 3 ways in particular. Now, there are, of course, other ways to compress, but generally in Linux, and specifically on the Linux Plus exam, we're going to look at gzip, bzip2, and xz. And this kind of goes in age. The oldest is gzip, and then bzip2 is the new kid on the block, but then xz is the even newer kid on the block. And in general, each one is offers a little bit better compression algorithm, okay? But it's important to know how to use all 3 of them. And in order to compress something with gzip, you use the gzip command. So you would say gzip and then the name of the file. And now what we're going to use is this -k flag. And all that does is it will keep the original uncompressed archive file. So it's going to keep our original file, because normally what it does, it compresses it and then it erases the old one, because you have a compressed version. Why would you want the original? Well, we're going to compress it a bunch of times. So -k just keeps the original file. That's all -k does. Okay. So we're going to do gzip -k, the file, to compress it. And we're going to do bzip2, which is the command to compress it with bzip2 compression. Again, we're going to use -k to keep that original file. And then same thing with xz. Now we did this in the Linux Essentials course, so I'm going to go quickly. All right. right? And then when we decompress it, we say gzip-d, the name of the file, or there's a second tool called gunzip, which looks like gunzip, the name of the file. These are completely the same. They're equivalent. You can do the original compression program gzip-d for decompress, or you can just say gunzip in the file. And the same thing with bzip or bunzip2, bunzip2 or bzip2 or bunzip2, and xz or unxz. So they all work for decompressing. There's a secondary tool, or you can use the original tool with the -d flag to make it happen. So let's look and compare how they do compressing. All right, so I'm going to clear the screen, and we have in the folder, we have archive.tar, and it's, like I said, it's just a tarred, not compressed file. And then we have our original stuff folder. So first let's do gzip. So gzip, I'm going to do -k so it keeps archive.tar. Otherwise I would just delete it. And we're going to say gzip archive.tar. And we do ls-l, we're going to see we have archive.tar.gz. It added its own extension. And sometimes you will see .tar.gz, sometimes you will see .tgz. It's the same thing. They mean the exact same thing. One is not better than the other. Just a lot of times people will shorten it, and instead of .tar.gz, it'll just be .tgz. Okay, just you'll see it both ways. All right, so let's do the other two really quickly. bzip2-k to keep the original archive.tar. This one takes a little bit longer because it's doing a little bit more compression. And then let's do xz without even looking. -k, we're going to keep the original file. Archive.tar. This will take even longer because it's doing even more compression, unless I'm wrong, but I think that's what we're going to see when we look at the results here. All right, ls-l, and sure enough, we have the original, which is like 86 megabytes, tar.gz, which is the gzipped one, is about 35, bz2 is 26, and then archive.tar.xz is only 13 megabytes. So again, xz is by far the most compressing one that there is, if that makes any sense. Now, since we have all of these copies, let's do some quick extraction and just see what it looks like. So rm-rf stuff. This is going to get rid of that folder. Let's get rid of the original archive. And now if we are going to uncompress it, we would do like gzip-d for decompress, archive.tar.gz, do that. And now if we do ls-l, we're going to see it erased itself. It erased that gz file, and it left us with an archive.tar, which is the original size again. Okay, so it uncompressed it, and so now we have that original tar. I'm going to get rid of that original tar file again, because we also have two more copies. Now we could use something like bzip2-d, or we could say bunzip2, archive.tar.bz2. Again, either one is going to do the same. And now we can see we have that original file again, and it's the exact same length. Well, let's erase it because we have one left. And in this case, let's do xz-d again for no good reason. Actually, I'm going to move one real quick. So let's move archive.tar.xz to archive.txz, because remember I said you'll see them shortened that way sometimes. And so now we have archive.txz, but it's still going to work exactly the same. It's going to be, so xz-d for decompress, and it's going to give us back that archive.tar file. And the archive.tar file, we could do tar -extract -f archive.tar. And now we have our stuff folder back, so we can get rid of archive.tar if we want, because we have all of our stuff back. Now, generally, we don't do it in two separate steps like that, because tar gives us the ability to call that third-party compression suite right at the same time that we're creating or extracting a file. So we're going to do the same thing even quicker with tar, and it will call those other commands. Because while it's important for you to understand that the compression part and the archiving part are different, generally we use tar and we do them at the same time, okay? And in order to do that, it will call one of those other compression suites on the command line. So what we would do is we would say something like tar-c for create, z for use gzip compression, and then f file.tgz, and then what it is we wanted to add. And then we would use that same sort of thing if we come across like a tbz file. We could say tar dash X for extract, dash lowercase j, I have no idea why it's lowercase j, but dash lowercase j means this is a bzip2 file, and it's going to use the bzip2 suite, and then F, the name of the file, and it will extract it. And then the same thing for gz compression, but in that case, the extra flag we use is capital J, and that will tell it to use the gz compression suite or decompression suite. So we're going to go through and do that. But then lastly, we're going to look at zip, which again, if you're from a Windows background, this is the one that you're most familiar with anyway. And zip archives and compresses by default in one step. So it is simpler. It doesn't do quite as good of a job of compressing, but it does compress and archive in one step. You do have to remember the -r flag, otherwise it doesn't recursively go through a folder. So basically you just say zip -r for recursive, the name of the file you want to create, and then what it is you want it to actually compress. And then to unzip it, you use the unzip command, the name of the file. That's it. So let's look at those really quickly and we'll be done. Let's clear the screen. We have our stuff folder. So first of all, let's create a compressed tar file in one step. So tar-c for create, and I'm going to use capital J. So I'm going to use the gz suite of compression. And then F, the name of the file, is going to be archive.txz. Okay, hopefully that makes sense because we're using the gz suite since we use the capital J flag. And then I wanted to use the stuff folder to make the archive. So we do that. It's going to take a while because remember gz has the highest compression rate. All right, and if we do ls-l, we're going to see we have that file. And again, it's 13 megabytes, just like it was when we did it in 2 steps. This doesn't give us better or worse compression. It just combines the act of archiving and compressing into one step by using this capital J flag or the lowercase j flag for bzip2 or the z flag for gzip compression. Anyway, so we're going to leave that there. We have the archive.txz. Now let's use zip because zip is available in Linux too. But here we're going to say zip. Remember -r, we have to say -r, otherwise it won't recursively go through the folder. And it was just like with cpio, we'll just end up with an empty folder compressed, and you could really shoot yourself in the foot if you think you have a backup and you don't. Okay, so zip -r, and then the name of the file. So I'm going to say archive.zip, and then what it is we want it to zip up, and that is the stuff folder. So I'm going to press enter, and it actually shows us verbosely all the stuff that it added. So that's a nice way to know. If it only showed you like an empty stuff folder, you'd be like, I should have a bunch of files in there. And if we do ls-l, we're going to see, sure enough, we have archive.zip, but check this out. So archive.txz is 13 megabytes. The zip file is 39, almost 40 megabytes. So zip doesn't do as good of a job. You can increase the compression rate, but out of the box, zip doesn't do as good of a job, but it does both compress and archive in one step. And then we can do rm-rf stuff one last time. Okay, so we only have those two things, and we can say unzip archive.zip, and it's going to bring everything back. If we look inside our stuff folder, everything is back. So I know that was kind of a whirlwind look at exactly how compression and archiving works in Linux. But again, if I went too quickly for you, I encourage you to go back and look at the compression and archiving video that I linked earlier. I'll try to put a link in the description as well, because we go through it a little bit more slowly with a few more examples. But hopefully the more in-depth stuff we covered made sense, and you should be able to not only understand what it is, but how to do it on Linux using multiple tools to accomplish whatever task you might need. Anyway, learn everything, do what you love, and most importantly, be kind. I'll see you at the next video.